Well, Tom, we're on our way to Heath Station today, and I guess you've never seen the old compressor plant.
No, I haven't, Paul. I'm looking forward to it.
Boy, I bet you're going to enjoy it. Right now, we're driving through the Allegheny National Forest. We've been in the forest for about 10 miles, and that's Clarion River beside us.
Oh, yeah, okay. Geez, that's a beautiful river.
Oh, a lot of fishing, canoeing. It's been cleaned up a whole lot over the years. This is certainly beautiful country out here.
Sure is.
This station seems to be located so far out from any civilization, but the purpose of it was in the center of the gas field. Yet it still pumps from the local production around, maybe around a 40-mile radius.
Is that right?
And the gas that it pumps is mainly sent north towards the New York and Buffalo, New York markets.
Look at that over there. Isn't that beautiful?
It sure is. The river bends away from us now, and we're coming right down into the valley where the station is. This little bridge is the creek for the cooling dam.
Oh, wow. Look at that. Isn't this neat?
Maybe when you go up around the corner, just slow up a little bit, and we can make a good view of the whole station. Pretty much unchanged since 1912.
Isn't that neat? Oh, I see something big inside there turning, don't I?
You sure do, and it looks like they're running.
Isn't that great? Wow, look at that beautiful tile exterior.
Well, we've called ahead and made some arrangements with National Fuel Gas, and Mike Mooney is the engineer today. And he promises to give us a tour of the station and let us see the equipment running.
Well, it looks like there's a lot to see here.
Boy, I think there is. I sort of have grown up at Heath Station. I think I've come out here for about 35 years now.
Wow.
We just pull up right here by the exhaust pipes.
Oh, listen to that sound, huh? Hi, I'm Tom Spencer, and with me is Dr. Paul Harvey of Cool Spring Power Museum. And Paul has a real treat for us here today. Paul, tell us a little bit about what we're going to see here today.
Okay, I sure can, Tom. We're at Heath Station. This is a natural gas compressing station belonging to Natural Fuel Gas Supply Company. It's probably the last station of its kind anyplace. We're going to be seeing 6 tandem double-acting 400 horsepower snow natural gas engines. First one installed in 1912.
Is that right?
These engines still run with make and break igniters.
Wow.
So I think this is probably the last of its kind in the country anyplace.
What a treat.
Tom, let's go over and meet our engineer, Mike Mooney.
Okay, Paul.
And we'll be able to have a look around.
All right. Wow, listen to that sound, huh?
Oh, it's always a pleasure to come in here.
I love it.
4 of the engines are exhausting out in this exhaust pit, and the other 2 go out back. And the upright pipes here beside us are the air intakes.
Oh, okay. Hi there.
How you doing?
Hi, Mike. How are you today?
Good, how are you?
Mike, I'd like you to meet Tom Spencer. He came out to see the snow engines.
How do you do, Mike? Boy, you got a really neat place here.
Oh, we're pretty proud of it. Would you like to take a look around?
We sure would.
Love to.
Must be nice to be an engineer and running 6 snow engines.
Yeah, it's a lot of fun.
Well, good.
Go over in the compressor building, take a look around.
All right.
I'd like to put on some hard hats. We have to.
Okay, fine.
Okay, we sure can.
There you go.
Thanks.
Thank you, Mike.
Gas is right ahead.
All right,
Okay,
great.
let's go over and see
Thanks.
some snow engines.
All right.
Shut it.
Wild. What do you think?
What do you think, Tom?
Man.
Pretty impressive, isn't it?
Oh, Mike, this is terrific.
Ever see anything like this?
Never. Never. Look at the size of these engines. Wow.
They've been doing what they're doing right now, compressing gas on a continuous basis since 1912.
That is incredible. And you got 6 of these engines in here.
6 here, we're running 5 of them at the time, right at this time.
Mike, Paul, this is a real treat, I'm telling you.
Great. It's been a treat for me for 30-some years now.
That is fabulous. Mike, you want to take us around and show us some of this machinery in here?
Sure, I'll show you how the engine, basic setup, how it operates, and on one particular engine. They all work in the same order, they're just different compressors.
Okay, great, let's take a look. Wow.
The basic setup is, it's a tandem, double-acting, horizontal engine. It has 4 cylinders in line. There are 2 pistons, they're solid pistons, and being double-acting, it fires on each side of that solid piston.
Basically like a steam engine.
Basically like a steam engine, only it uses natural gas for fuel. It's an internal combustion, 4-cylinder, 4-cycle engine. It has everything out in the open. It has a camshaft with rocker arms, intake, and exhaust valves. Only they're out in the open where you can see them working.
Right, that's neat.
Another thing that's very unique about these engines in this day and age is, number one, that they are in original condition, and we are still using the original style make and break ignition, or an igniter.
Can you show us that, Mike?
Yeah, it's what it is. There's 2 igniters for each cylinder. They're just redundancy backup.
Yeah.
What it is basic idea of it, you could say it's a heavy-duty set of points. We have a 12-volt battery system over in the shop. That comes over to the igniter. And normally they're open. If you want to wait right here, I'll bring one over and show it to you.
That'd be great.
What the igniter looks like.
All right.
This section from here is actually in the firing cylinder. Normally they're gapped open only about 1/8 of an inch.
Right in here.
Right there. When it starts up the ramp on the camshaft,
which is right here,
there's a trip rod. That lets these come together and it grounds it. That takes the low voltage, 12 volt, as low voltage, goes into a coil box over on the wall.
Okay.
Right inside the door there when we came in. When it snaps off the end of that ramp on the camshaft and breaks open, it arcs across here, and that fires the fuel. So in a sense it is like a set of points, but it fires the fuel when it breaks open and arcs.
Make and break.
Make and break.
Yeah.
And one thing that they had a chance at one time, there was a conversion, convert this type of engine to spark plugs, and they would have driven a magneto off the camshaft somewhere.
Okay.
But they declined to do it at the time, and it's nice that they did, because
that makes it really neat.
They're like this. Like I say, it's a very unique ignition system. Not only the engines are unique that they're still running, but running on that type of ignition system is something you'll never see anywhere else.
Makes it even that much rarer.
Oh yeah.
And there's 2 igniters in each cylinder, right?
Right, it just back up. They can, in fact, there are switches at the coil box. You can switch them off, and it will still run on one igniter. And we can tell by the little, what we call a telltale.
Can you show us over there what you're talking about?
These are the coils. As you can see, these little telltales going in, that is the high voltage breaking out of the coil at the time of ignition. So if they would quit, we can look at that, and if there's any problems with those, we can tell which cylinder it is, because their number, it just has the firing order 1, 2, 3, 4, and the inboard and outboard as their position on the cylinder. So we can tell which one is going bad, and sometimes we can fix them as they are in the engine. Sometimes we can't fix them and we'll shut the engine down and change it. If I get set up, I have done it before, that I get a new igniter ready to go and all my tools. I can shut the engine down, change the igniter, and start the engine up in about 5 minutes.
Is that right?
So we don't really miss the downtime on the engine. And then after a long time, it depends on the hours on the engine. They get to the point where all 8 of them need change. So we'll shut that engine down for several hours.
Change
the whole out. Because they do wear, they burn. Because these burn. When we rebuild them here, we just weld that up with a little bit of weld, and there's a little brass washer. That seals the pressure off from coming out through the body.
Okay.
That brass will get bad, it'll burn through. So we repair them, rebuild them here.
Now, of course, this is insulated right here.
Yeah, that's mica chips.
Okay.
That insulates it. So that in a sense, this is where the hot
side of
from the battery.
Right.
And then that's tied in through the coils where it switches it.
And actually what it does is trip off of this right here, is that right?
Just a washer sits there and trips that rod.
And that trips it.
So it's a very simple system, and you know there is maybe a better quality spark with a spark plug, but like I say, it's so nice to have them the way they are.
Yeah, really. Having them all original makes it great. That's really interesting, Mike.
This is where we start the engine at.
Right here.
Right. There's a main oil valve which turns on the lubricating oil for the engine. There's a valve that
where does that oil come from?
Well, there's another unique thing about these engines are they don't really have an oil sump or an oil pan. All the lubricating oil that goes through the engine, that goes through different drains into tanks in the basement. And there's 2 sets of tanks at each end of the building. They have water at the bottom. The oil draining out, and it's of all engines running, goes through this oil system. The oil goes in the bottom of the tank from gravity feed from the engine. As it comes up through the water, it breaks up into small droplets and seeks the top of the water. Well, going up through the water, the heavy sludge or dirt will fall out in the water. Then the oil congeals again on top of the water and goes over a funnel. And it goes through another tank. It does 2 sets of water tanks. There's an oil pump, a 2-stage oil pump that is driven off the camshaft of the engine. The first stage pumps that oil from the tanks in the basement up to a filter sack tank, which is on the far wall. We can look at that later.
Okay.
There's a series of cloth sacks, open top cloth sacks. The oil goes down through that cloth sack and it filters it again. It catches a lot of dirt. Goes through another set of water baffles in the bottom of that tank. Then it is the second stage of the engine-driven pump, pumps it into the main oil system. So it's a low pressure system. There's not a lot of pressure on it. We also have an overhead tank. Now it maintains a level in that tank, and we can change that if we want to.
That's the tank up there in the beams, right?
And it has a float on the far end. We can tell the level in that tank. And once the engines are established and running, the oil level never really changes, because what we put into the engine drains out of the engine, is filtered, and comes back to the engine. The main reason for the overhead tank is to have gravity feed when the engines first start, because until the engine runs, we aren't pumping oil. So the overhead tank gravity feeds the oil to the engines once they get started, and the oil, especially if they set a while and the oil's cold, it takes a while to seek its level. But once the oil warms up and the engines are pumping, it goes right back to the same level. There are certain places where water does mix with the drain oil. And through our water tanks, we can drain that water off. It's just pure water. And we take that water off, and that keeps the oil level constant all the time. We never, in a sense, change the oil.
Mike, can you describe to us how one of these engines actually operates?
Sure. We kind of start at this end of the engine. We have what we call the tail slide. That supports the end of the rod for number 1 cylinder. And it also, because the rods and pistons in this engine are internally cooled with water, that's an outlet for the water. So there's a water drain that comes out the end of the rod.
I see.
Moving up, we go into the number 1 cylinder.
Yeah.
This is your intake valve and the exhaust valve. It's on an external, what they call valve chest. It drives both intake and exhaust valves off of one cam load. The mixing chamber up here, that's where we mix our fuel. The air comes in from outside. This is the fuel, the gas comes in here.
I see.
It mixes it in there, goes into each cylinder, so that it shares one mixing chamber for 1 and 2 cylinders as we're looking at them right now. There's a hole about that big around that actually goes into the main cylinder. So it fires in this valve chest first, and then the flame, the combustion flame progresses into the main cylinder. As the exhaust goes out here and out through, it goes down through this water-cooled jacket down to the main exhaust manifold in the pit there.
Yeah,
so we water cool around the combustion chamber, around the cylinder jacket itself, plus we also water cool the intake valve cage and the first part of the exhaust. We water cool that.
All right. That's interesting. That's your exhaust valve on the bottom then, right?
You can see from down here where the nut is, up to right about here, that valve and the stem on that valve is about 3
feet. Wow.
I can show you some later. They're big valves. Their head is probably about 8 inches across.
Wow.
Another thing that is at this end of the engine is the starting system. They have a direct air injection into the cylinder. It has a, you can see it has a keyed rotor. That rotor that's turning in there right now is keyed to the camshaft, so it's on each cylinder's power stroke. So when the air comes in, it goes into that cylinder on its power stroke and just pushes the piston down. Then on the backstroke back, it just blows that air out the exhaust. And that's,
the same as if it were running, basically, right?
The same as if it were running. That gets it rolling over. I add my ignition through a switch and turn on the fuel here at the starting stand, and that's what all it takes.
And away she goes.
Away she goes.
Where is the air actually introduced into the cylinder?
Oh, on this other engine, it's on the off side. It's just a poppet valve, more or less.
Okay.
It goes in. When we have them, after we have them started, we put a key in here to lock that valve so it doesn't suck open on the intake stroke.
I see.
Okay, what they call the side shaft, it is a camshaft.
Right.
It's just an external camshaft. And as I was explained to you before, all the cylinders run, the intake and the exhaust valves are driven off of one cam load, which is kind of a unique way of doing it.
Yeah, it is.
Plus, also, as I was explaining on the igniter, on the ignition, this little ramp, that's what trips the igniter on the make and break ignition. These Richardson boxes, they're pressured oilers. Because it has a horizontal layout and your piston rods actually go through the center of the head of the engine, it has a packing gland around that rod, packing case. We oil the packing cases. There's cast iron rings in there that hold the pressure back, and then there's Babbitt rings in there that wipe the oil off of it. And that holds the pressure in the cylinder so it won't come out the rod. We also have oilers that pressure oil the cylinder walls so your piston rings are oiled. So they're driven off a gear case right here off the camshaft and through this stroking pump. And you can see we can adjust those little needle valves for how much oil we want to go into either the packing cases or the cylinder walls to oil them. This one oils 1 and 2, and this box oils 3 and 4.
Now you refill these from here?
Yeah, that's pressure oiled. We're using a newer oil right now. It's a very low ash oil. So when it does burn, especially in the cylinders or the packing case, it will burn, but it produces very little carbon. We used to use an old oil that burnt a lot, and we had trouble with the packing cases getting hot.
Now this is basically here, Mike, is a carbon copy of what we have down there, right? This is
Right.
1 and 2 and 3 and 4. This is 3 and 4 down here.
The cylinder sections would interchange.
Okay.
And as they are right now, this is 3 and that is 4.
Now if we look down under here, back under here, you can see the piston rod back there behind the lubricator.
Right, that's
Sliding back and forth.
our center slide shoe just supports the 2 rods. It'd be to the left would be the rod for number 2 cylinder. To the right of it, as we're looking at it, is a rod for number 3 cylinder. And that just supports the rods in the middle to hold their weight up. Like I say, it's the same setup on these 3 and 4 as 1 and 2. This is that 2-stage oil pump I was telling you about for our oil system. So it's driven off the camshaft.
Right here with this eccentric.
Right.
And this is the pump down here on the bottom.
Yeah, it's top and bottom. Like I say, it's a 2-stage. First stage pumps from the basement tanks to the filter sack tank, then from the filter sack tank into the oil system with the second stage. It also has a rod here going up to the top, or McCord, that's the brand name, McCord lubricator. That lubricates the compressor cylinder only.
Oh really? This
Yeah.
right
It has a packing case on this particular compressor. It has 2 packing cases on each end, and I can explain how that works, plus one that oils the cylinder wall in your compressor for your compressor rings. That's the governor for the engine. That was the only actual thing that was not built by Snow. It's a Yons brand name governor.
How do you spell that?
I'm not even sure how you spell it.
Yonz, Y-O-N-Z.
Something like that, yeah. And what it does, it's a fly ball governor. It's a these are throttle governed engines. They're
Throttle governed.
throttle governed all the time.
Yeah.
It's a standard fly ball governor, only the weights are inside that case because they're in an oil bath.
Oh, okay.
And we get up on top of the engine, and there's a little cover to take off and oil that. So that just keeps the oil from slinging around that cover. That little spoked hand wheel, there you go. That's how we control the speed. Inside the column under that is a spring. And as we pull that hand wheel down, it puts more tension on the spring,
Okay.
which keeps the governor weights from going out as quick. So that controls and makes the engine run faster. It governors back is the way it works. When the engine is setting, not running, it's wide open. As soon as the engine comes up to speed and the governor weights picks up, it throttles back
Throttles it
to
back.
control the speed. So if I want to change that,
Something breaks, look out, right?
yeah, I have had an engine, number 3. It broke the governor belt because the belt is driven right off the crankshaft. So when the belt broke, the engine went to a wide open phase on the governor. It has a trip in the flywheel. We might be able to show it on the engine that's not running, but there's a spring-loaded weight in the flywheel face, and once it gets to a certain inertia from overspeeding, that weight will come out and trip this lever. There's a little electric switch in here, and this lever,
And that'll kill your battery?
that kills the connection for the ignition, and will shut the engine down.
Boy, they thought of everything, though, didn't they?
Oh yeah. Yeah, they had to have some type of overspeed because you can't always control what will happen. Like I say, it did happen at one time.
Now tell us a little bit about this flywheel end of this engine. How big is this flywheel? This thing is really neat.
Well, by our estimates, the flywheel weighs approximately 12 tons. We're not quite sure, but we have a pretty good guess. About 12 foot in diameter. It was made in one piece, and then they would turn it in one piece, and then they cut it so they could clamp it around the crankshaft.
And that way it would bite the shaft.
Right. that can show you on the other engine, number 3 there, that's not running, how that's set up.
All right.
But it is set up, and also the split in the flywheel by the key on the crankshaft. There's a big key. The key's the flywheel to the crankshaft. The split in the flywheel is lined up with the crank throw. So we know where the crank position is by the split in the flywheel.
Maybe we can take a look at that right now, and then we'll get back to the...
well, we can work around that way, right? Okay, Tom, this is a flywheel on the engine that is running at the time, and you can see that's a big, what they call a dog bone key. And that flywheel is split the whole way through.
Yep.
And then that dog bone locks it back together. And so they put it around the crankshaft, and there's a great big key on it. You can see down there. That key locks the flywheel to the crankshaft. Then it's bolted through with the big bolts and nuts that you see.
Right out here.
And then also, like I say, the dog bones lock the two flywheel halves together. And that would correspond, like you say, the split in the flywheel corresponds with the crank throw. So that's how we time the engine. We'd like to have it in a certain position for starting. The split anywhere from approximately, as you're looking at it, 10 o'clock to about noon on a clock face, and that gives it a chance to roll to get started. Over here, not sure if you can see it, right down there, that's the overtrip rod in the place of the flywheel. It's a little hard to see down there.
What is that, spring loaded? Or?
It's spring loaded. It's a solid rod with a spring behind it. And when it gets up to a certain speed, the inertia
throws it out.
Right. And when it comes up, it would just hit this lever.
Here, Bob.
You can see I set the switch when I go to start the engine. If it would overspeed, it just hits that lever and shuts the ignition system off.
And you say you had that happen to you once?
Yeah, this particular engine, the belt broke. And the governor went to wide open. And with no way to control it, it run pretty fast. I thought it was going to get away from me. I hit the fuel at the starting stand. I could cut the fuel off, and I shut it off at the same time the overspeed did trip. We didn't have
Did you hear it take off? Were you hearing it?
Oh, yeah, and it took off. This is the outboard bearing for the crankshaft. It's supported on this outboard end, plus there's also a big bearing, or inboard main we call it, on the other side of the flywheel. We oil this bearing, and this is part of the oil that drains in through the main oil system. We have very little trouble with these bearings at all. Also on this engine, as you can see, there's a belt driven off the crankshaft.
I see that.
That belt goes down in the basement, and we have a triplex Deming pump. It's a water pump. We pump water out of the pond out back of the building, and that supplements our cooling water for the engines.
Oh, okay.
So this engine, number 4, and the other one, number 6, that drive, there's 2 water pumps in the basement that are belt driven off those 2 engines. And they're on all the time. If the engine's running, it's pumping water for us. Once we get past about 2 of the snows running, we have to supplement our water. So we try to have something, one of the engines, 4 or 6 running to help with our cooling water. You can get up here and maybe take a look at the inboard main bearing. There's a big cap on top of the main frame, and under that is what we call our inboard main. It's a different style of bearing in that it only covers approximately 3/4 of the crankshaft area. The top of the crankshaft is open.
Is that right?
It's more, it takes so much weight. The bottom section of the bearing stays in place, and then there's what we call quarter boxes. The quarter box on this side of the crankshaft stays in place. The one on the other side of the crankshaft is adjustable by a wedge. So as it gets loose by wear, we can take up that quarter box by driving a wedge against the bearing block itself. And that takes up the wear. So we adjust them on occasion. Also right here inside is the camshaft drive for this particular engine. Now these are a little bit later engines. These are later design engine, and they have a type of camshaft drive that is quiet. It has in a sense, like a herringbone gear and a worm drive. Where number 1 and number 2 are the early engines. They have a straight cut design gear, and when we get up around them, you can hear the gear ring a lot more.
It's like a backlash.
They have a backlash to them, and it makes the gears ring a little bit more. This is a lot more quiet and tighter camshaft drive.
He can get right up there, can he?
Sure.
Kind of gives you the idea of the size.
Okay, Tom, this is the compressors for the engine. As I was telling you about the McCord box, up on top of the mainframe, these are the oil lines. There's a packing case around the compressor rod. Seals the pressure of the compressor off around the rod. There's a oiler for the cylinder walls itself for the piston, compressor piston rings. And what's unique about these compressors, they have what they call a hurricane valve in the compressor piston. And on this outboard end of the compressor, there's also a packing case. In that packing case and in the tube for our inlet gas, there's a long tube. It's about 5-inch diameter, and it screws into the piston face. The fresh gas, the inlet gas, goes inside the piston. There's a valve plate in the piston face, and that's our true inlet valve. And it opens up to let the fresh gas come in after a compression stroke. So on the inlet stroke, the gas comes in, and in a sense it's cool, so it cools the piston with the fresh gas from inside. Then on the compression stroke, that plate closes. When it comes up to discharge pressure, there's little poppet valves, or discharge valves are right here. These are the discharge valves. You can feel the heat coming off there right now. This one's running a little over 300 degrees, the gas temperature compressed.
Is that right? Yeah. It comes in at what, about 60 degrees?
Probably about 60 degrees, yeah.
And goes out at like around 300?
300. So we take it outside and cool it.
Oh, okay. Now these are your valves here then?
Right, that's the discharge valve. And this is what we call our low stage compressor. We two-stage the gas with the snows. The first stage that we're looking at right now is compressing the gas from right about 10 pounds to about 150 pounds. Then it goes into the high stage. Number 1 engine is a high stage compressor. That's compressing the gas from the 150 to almost 300 pounds today. This is just some of our valve arrangements. This is the main valve or gate to let the inlet gas into the compressor.
Right here.
We come around this side. We also cool the compressor jacket with water, and that's the cooling water coming out. So we circulate it through the heads and around the jacket to cool the compressor, because you can see our gas temperature is up to 300 degrees.
That's right.
Going back along this side of the engine, we get up to one thing we can do. This is the oiler for the crank pin bearing on the connecting rod. It's an open-sided crank. So the crank, there's only one journal.
Right.
Okay, open-sided crank. And so this has a slinger that goes around, and it turns around with the crank as it's going around to oil that crank pin and bearing. It's a Babbitt bearing. It's wedge adjustable, just like all the bearings on this engine in a sense are adjustable by wedges. We can take this little inspection cover. Now back in the old days, what you used to do is reach up inside there and hold your hand just right, and you would feel the crank as it come around, and you'd actually put your finger
It actually rub you like that.
right on the connecting rod as it come around. Well, that wasn't a very good thing to do, but they did it in the old days. Today, we use this. It's an infrared heat gun. You just point it at whatever you want to take. So we just hold it up in there.
And you're aiming right at the crank pin.
Right at the crank pin. It's about 114 degrees, which is good temperature.
Good temperature.
That's not bad at all.
What would be a high temperature? Over 200?
Oh yeah. at real high temperature. Of course, you know, using Babbitt with its melting point is probably in the 700 degree range, but so you don't want to let it get much hotter than 200 degrees because it just builds up that heat. But you just add your hand on there. That's the water reservoir for the telescoping water pump. That's how the water goes up through the rods. Inside the mainframe, there's a long cast brass box, in a sense, and at the end of that is a packing gland, and there's a brass tube, about 2-inch diameter brass tube that runs in that packing gland. That brass tube is bolted to our main crosshead inside the mainframe.
Okay.
And it has an elbow. So that's where the water is supplied, and when it goes into that crosshead, it then goes through all the rods. So it goes through number 4 rod and the piston for 3 and 4. There's a top and bottom to the piston. They're cored. And there is a top and bottom, so the water has to go through at a certain...
Travel through there and circulate through the piston itself.
Right, to help cool the piston and the rods internally. So right inside this cover is this telescoping water pump, and it goes right with. It's a 36-inch stroke. That's what the engine has, and it goes back and forth and pumps that water up through the rods. These little oilers here, there's just slides in there on that main crosshead. It's really heavy. In a sense, it also has what you could call your wrist pin.
Okay.
End of your connecting rod. And so we have Babbitt shoes on that crosshead, and they're set in cast iron that's machined out slides. And so we oil those slides the same as the center slide and the tail shoe slide.
Right.
And we oil the top. There's a slide on the top of that crosshead. We oil it up there.
These are really neat engines, Mike.
Yeah. Coming around this side, of course, these are the air valves we talked about for the start air.
Right.
This tube, that's your air coming in.
This is fresh air intake for the engine.
Right. In a sense, this whole, what we call the subbase under the cylinders, the whole thing is the air manifold.
Oh,
So
really?
it's the air manifold plus the cylinders set on it. And they're set on slides. We never measured
Right
it.
here?
Right. And it has little grease cups.
Yeah.
That's set, so when they warm up, they can expand. And this is an expansion band right here. This is the water outside of the water jacket, and under this, it's sealed off with O-rings, but it lets the cylinders stretch out as they warm up. They'll move a little bit.
The engines are so big that with the temperature, they actually grow inside.
It will grow and it'll move a little bit.
And it'll float right here.
Right. It's a sense, it's like a dovetail to hold it in place, but it lets it slide back and forth.
This way.
Right. So this is the intake air, comes out of the manifold up around the top of the engine and into the back side of the mixer. Then we also cool the jacket. This is cored out. There's inspection covers up here and here. And that's the water coming out of the water jacket around the cylinders. We also use the same water to cool the heads. The heads are cored, so they have water cooling in them. Now this is the opposite side of this, the center shoe that we were looking at earlier. And it has a little drip oiler. It goes
here.
Goes into those crosses in the bottom of the slide to spread the oil out. And it has a Babbitt shoe. And that supports, in a sense, what we're looking at is the opposite side. So to the left of us is the rod for 3, and to the right is the rod for number 2 cylinder.
Yeah.
That just holds them up. And you can see that water passages comes in the top of the head and out the bottom. There's a water pipe in there. Same setup, like I say, in a sense, a cylinder set is just 2 cylinders. These could have been interchanged when they were put on the engine.
Yep.
The same castings, everything is the same. We can get up here.
This is your cooling water.
That's the cooling water coming out of the cylinder jacket itself. And we get up here again, we can see this is a tail slide. And if you can hear that little...
That's the water,
That little slopping noise, that's the water coming up through the rod. And this gives us a good chance, because it's out in the open, to look at the rod packing case. And that big ring is just a ring that holds the packing case into the head. And it has, like I said, a set of cast iron rings that hold the pressure. Then there's, I think, 3 sets of Babbitt wiper rings to wipe the oil off it because we pressure oil it. And that's what holds your firing pressure back. Now, they're not a high firing pressure. They're only like 90 or 100 pounds firing pressure.
Oh, really?
Yeah.
Cool.
That's not a lot, but
No.
but it's a lot of volume because of the size of the cylinder.
What are we doing here, Mike?
Well, this is how you bar the engine over, what we call barring the engine over, to get it in the right starting position, like I was telling you about before.
Yeah.
Where we like to have the split in the flywheel roughly 10 to 12 o'clock. So use this barn stick, and there's a special little jack in here. Everybody wonders what the notches in the flywheel are for. That's what we call barring it over. This is our timing mark.
Okay.
The ignition timing is roughly 15 degrees before top dead center. We use this point right here and the mark, and we can put a regular timing light on the ignition system and set the timing. Another little thing here, if you look real close, there's a hole in the flywheel. An engine analyzer. It's an oscilloscope set up for analyzing engines of this type. It has a magnetic pickup. That is true top dead center. So we can put a magnetic pickup in there. That's also how we time the engine with the analyzer, because that's the true top dead center. And we use that to set our firing pressures plus the ignition also.
Back now, huh? Are you getting compression up?
Going up against the compressor pressure. That'll be all right. That's part of what this little, you were asking about that handle?
Yeah.
Well, it works. You just kind of put that in, that blocks the flywheel from rolling back. A couple more.
God damn it. I gotta mess with it and mess it up.
Okay, it should roll over good there. Okay, I just showed you one of the engines that was running in the basic procedure how it works. This engine over here, number 3, we recently worked on it. We can give it a little test run if you want to see how the starting procedure's like. Now, I'm going to be kind of busy taking care of some things, and Paul's been here a few times. He knows what I'll be doing. Maybe he can explain it to you while I'm taking care of it, and then we'll get it running.
Sounds great, Mike.
Okay.
Okay, I think we can do that. I think right now Mike's going over to the control pad. He's turning on the lubricating oil and the water to the engine. All the controls are up there. One of the hand wheels is the engine gas, one is the starting air, one's the oil, and one's the compressed air. The white knob then is the switch for turning on the current. We've seen the telltale box on the side already. Right now he's going through and checking all the water and the oilers, turning on the oilers, making sure the water is flowing through all the heads and the cylinders and the water passages. I think he already showed you, but he just made sure the safety of the flywheel, the overspeed, was released, so we have continuity of current. Checking another oiler there on the outboard bearing. turning on other oilers and going around the compressor right now. Turning on the bypass to bypass the compressor for starting. This engine, Tom, is the other high stage. I think Mike has told you that there's 4 low stage engines, and with the 5 running right now, that we're running 4 low stages into number 1, which is the high, which has the big National Transit compressor. And number 3 that Mike's going to start right now is another high stage. To make sure that the suction and the discharge valves are on. Okay, he's checking the oil into the connecting rod right now. And checking the oilers on the crosshead, which is inside the tin covers. Okay, so it looks like everything's ready to go, Mike.
We're all ready to go. We'll see if we can get it running here.
You'll start it on the gas cock first and then turn it onto the regulator, right?
Right. Basically what we do is sometimes you have to play with the main fuel valve a little bit to get it run. And once it fires, it's wide open with the fuel when the governor catches it.
You have to get that hammer handle out of the flywheel down there, or does that come out by itself?
No, that's to keep the flywheel from coming backwards out of the starting position.
Okay, Mike.
Exhaust?
Yeah.
This place is really neat, I'm telling you. I wonder what the difference in the sound is out there with that 4th engine running. Sharp. What I like to do, can we get him up, like let him go up a ladder down there so he can shine back across all the engines running? Oh, you think that'll look sharp? Well, you know, these snow engines in here are really great. This is terrific. What other type of equipment did Snow make back in the old days?
Well, Snow actually started building steam engines. The gentleman's name was Franklin Francis Snow, F.F. Snow. And he was originally in Benton Harbor, Michigan, moved to Buffalo and with the Snow Steam Pump Works. So the original engines were some of the Snow pumping engines. Oh, there's one of those being set up down at Rough and Tumble. Came from the York Water Works. Lansing, Michigan still has a Snow pump engine. I remember seeing one in Boston. They were pretty much coreless valve design waterworks engines. They made them very large. Some of the old books show some walking beam designs, but I've never seen any of that actually existing. I'm not exactly sure when the design for the Snow gas engine came out. The nameplates here tell us that the first two engines, number 235 and 236, were built in 1912. The rest of the engines were built in 1915 and 1916, and number 8 and number 6 were built in 1917. The production was obviously pretty limited because they went from 1912 for 236 to 1917 for about 320. Their gas engine production, though, they built some very large units.
How big, Paul?
They built blowing engines for the steel mill. This morning I was just looking over a couple of the old specs before you got here. We're looking at one that was 42-inch bore by 60-inch stroke with an 84-inch bore blowing cylinder on.
84-inch. Wow.
Their biggest engines they built were actually the ones that put them out of business. These were built for San Mateo Power in San Francisco, California. 5,000 horsepower.
Holy smokes.
So
these here
are 400.
Like 400.
They were huge.
Wow.
And the contract called for them to be regulated by the governor to within 2% of RPM for no load to full load. They could not achieve anything more than 2.25%, and the power company defaulted on paying for them. And that essentially put Snow out of business. Snow then was, the company, the shops, became Worthington, the same Worthington that we know today.
Worthington Pump Company.
Worthington Pump Company. And during the time, Snow had also absorbed the Hawley Pump Company. And the latest time it was Worthington CIE, Worthington Compressor Engines International. Okay, Tom, it looks like we had a good run on number 3, and Mike's shutting her down now.
You know what I want to do, Paul? I want to try to get Mike over here and see if we can get some dimensions on these engines. Bore, stroke, you know, the amount of fuel they burn, that type of information, if we can get that from Mike as soon as he gets finished shutting this engine down.
Has to make sure all the water's turned off and all the oilers are turned off, and the engine pretty much rolls back into a starting position.
Great watching all 6 of these babies run, huh?
Yeah, like I say, I think it's the only third time in my life that I've seen all 6 run.
You said you've been coming here since what, the 50s?
Yeah, since the late 50s. I think while we're waiting for Mike to come back, let's just go over and look at the nameplate on this engine. Number 4. tells us it's
There's your
two
size right here.
cylinders, which means it's a tandem, 20-inch bore by 30-inch stroke. Now this engine has an Ingersoll Rand compressor, so they had no idea what size it would be. But if it was going to have a snow compressor and came with its own compressor from the factory, the middle place would denote compressor bore. So the power cylinders are 20 by 36. This one happens to be number 304, built in 1915.
It's a successor on there, huh?
Yeah.
Succeeding who? Succeeding what?
Apparently, the International Steam Pump Company was a holding company that was over Snow and Holly.
Oh, really?
Right.
So this
See
is the
very
parent.
little about that
International Steam Pump Company is the
successor.
successor.
A very brief time before Worthington. But each engine has one of the nice fancy display plates and the little information plate that we just looked at. Tom, we have some spare parts, and I think Mike is making his rounds on the engine. So let's go down and look around in the basement.
Let's take a look.
Boy, it's hot down here today, but there are a lot of spares here.
Boy, it sure is. Wow, look at the whole governor assembly.
Yeah, right here we have a complete governor assembly. Of course, it's laying down on its side.
Yeah, look at that. A complete unit, though.
And a green one, so it's been from some other station.
Yeah.
I think everything laying back here are some snow parts.
I bet some of that stuff back there is brand new, you know?
I think here we see some of the big wrenches that are used to,
Oh, yeah, wow.
to put
Look
the
at the
engine
size of
together.
some of these.
Yeah, and from working on the 600 horse snow, I know that this one is the lock nut wrench for the piston rod between the two cylinders.
Uh-huh.
Boy, these are the exhaust pipes, and
Boy, they're
this
hot,
stuff's
aren't
even
they?
hot. You bet.
Those pipes are radiating
All
off
the little
bloodletting.
sledging wrenches that
Yeah.
fit into special places.
Boy,
Another
oh
big
boy.
wrench. These are the exhaust pipes. Snow always used an exhaust pipe that flanged up against the valve chest, and they're water jacketed and water cooled. I think this is just a pressure dome from a pump, and that's part of one of the cooling water pumps that we'll see here. Here's
oh
kind of
boy.
an interesting piece. This is a main crosshead.
Wow, look at that.
And
That's a
the
big hunk of
shoe
iron
is
there.
gone from it right now. So this side would be down,
Uh-huh.
and the two tie rods would go in here. The piston rod would screw in there, and this is the joint where the telescoping tube to the water that cools the piston would go in.
Wow.
These are intake chests, and these are mixers. We saw those in operation up on top of the engines. It's kind of interesting while we're right here. These are new, of course, but the metallic packing rings that go around the piston rod to make a seal. It's metallic packing that lines up in
Oh, look at that.
3 pieces to make a circle.
Huh.
And each one has a little spring goes around it, and that's what makes the seal up against the piston rod to hold the compression pressure instead of the usual manila packing that we think about.
Pretty interesting.
Let's go on over that way. I see some
right, Paul.
pistons over there, Tom.
Wow, they're good size, aren't they?
Yeah, they sure are. On top here is a compressor piston
Uh-huh.
and the rod. I think the things that are interesting are the next three
These are engine pistons,
engine
right?
pistons. And as we've been saying, these are double acting engines. So when the piston rod goes in the cylinder, there's a head on each end with some metallic packing, and the rings go in here, and there's combustion. It fires on this side of the piston, pushing it over, fires on this side of the piston, pushing it back.
Boy, they're big and heavy, Paul.
Mike, what is that gear there? I don't recognize that.
Well, that's the camshaft drive gear for number 1 or number 2. Remember we were talking about that straight cut gear with the ringing noise? Okay, there's in a sense, there's this small gear clamps right around the crankshaft itself.
Yeah.
Drives this big one, then comes down to the bevel, and the bevel turns the camshaft. So that's where it's straight cut gears, and that's where you get that ringing noise. If you look over next to it, there's one of the herringbone style. That's for the later models. This is what would actually clamp around the crankshaft itself. They're split with bolts, and so they clamp around. And then they drive out the bottom, they drive over, and then it drives another different arrangement for the camshaft, but it ends up turning the camshaft the same type way.
Mike, you want to say a little bit about how the piston rod seals in the head?
Okay, we were talking about
Is this the seal right here with the packing nut?
No, these are, I'm not really sure what these are for. But that's the actual fire checks, if we call them. It's the rod packing. Now these are the solid. The original style were solid rings.
Okay.
And which worked, but to change them, you had to thread them off, take them off the rod. And when they get plugged up, they were really jammed on, hard to clean. So in later years, what we've taken is these solid cast iron rings and tangent cut them, like we were looking at the compressor packing.
Yeah.
That's what they call a tangent cut, cutting a groove in it for a garter spring, so they would collapse. Plus, it made them a lot easier to change because you could take them off the rod. So you take them off, clean them up, put them back, clean the rod, put them back on, put a new spring on them. A lot of times you'll get in there and the spring will be broken. That's why they weren't working. Power ring for the engine piston. Now you can see that one's been broke.
Yeah, look at the size of that.
That's the rings. We have a whole stack of new ones ready to go if we ever need them.
Is that right?
We'll send them out, have them turned. The machinist from up at Roystone will come down, measure the cylinder, then he has a faceplate on his lathe to turn those to our diameter. Right behind you there, that's one of the Deming pumps. It's belt driven off of, this is number 4 with the we're under, and it's driving this water pump that's pumping out of the pond and through its discharge line, discharging into our main water header for cooling water for the snows. You kind of look up through there past the belt, that's the flywheel.
Oh yeah, there it is. Gas here.
Yeah, that pipe you just ducked under there, it's a discharge gas coming right out of number 4's compressor. And like I say, it's about 310 degrees right now, so it's pretty warm. We can kind of mosey over here, we can get by.
Wow, look at this neat little pump.
This is what we call our donkey pump.
Look at this neat little...
It's an air-powered pump, and we can use that to pump the oil in the standard oil system for the snows that are driven off the engine pumps. If we would need to supplement that or move the oil around when none of the engines are running, we can use this little air-powered pump and either pump it out of the basement to the filter sack tank or the filter sack tank overhead. And
neat little job.
Yeah. And then right behind us here is the valves for the engine.
And these are the regular engine valves here, huh?
Yeah, if you want to hang on to the mic here.
All right.
Wow, look at how heavy that is. Look at that.
That's an exhaust valve. That has so much, because the spring is so long on it.
Yeah. This is your seat right here, Mike, right?
That's where it seats. This is just to help the exhaust slow down.
And it's probably so massive to keep it cool too, right?
These are the intake valves. They don't have a skirt on them. They're shorter because of, they're on top, as you can see on the valve cages on the engine.
Wow.
We have a reamer we can run down, runs a guide in the valve guide itself, and it has cut. We can recut the seats, and smooth them up, and then we put the valves down in a little lapping compound, over compound. We have a thing that clamps on the bottom of the thread and sit there. And then we sit there and we turn the valve, spin it like this with the lapping compound to lap it into the seat. So we gathered these up over the years because the company used to have a lot of these engines, and luckily they were smart enough to gather up the extra parts out of some of the engines that they scrapped over the years. So they have a pretty good supply of valves anyway.
So you've got about everything left now that your company owns as far as snow
everything
stuff
that's available for the snows is here.
It's here, yeah. Wow, that's incredible. Watch your toes. I don't like that. Is that going to stay there, Mike? Maybe better put that back up. Oh, that's the cutter. That's your valve seat cutter? I'm afraid that one's going to fall, Mike. Hold on to it. Little bit of weight there, Mike.
Yeah, they're pretty heavy. Now this is that valve seat cutter I saw. Like I say, we can run it right down in the guide.
Your guide would be here.
Right.
And then this is the cutter itself.
And then we cut the seat in if it's got bad marks on it. If it's burned a little bit, especially on the exhaust, they'll get burned a little bit. And then, like I say, then we'll take the valve that we put in it and also lap it into that seat, even though we've cut it. So
you have to do that very often, or?
Not very often lately. Now, when they were running a lot, in the past years, when they run all the time, that was probably about once a year thing. We tried to set them up that, on a certain, every so often we'd run, within a year's time, we'd redo the valves on all the engines, sometime through the year. But like I say, we just haven't been running them that much lately, so it isn't necessary to do it. It's a little warm down here.
A little bit. Is that another cutter down there, Mike? That looks like another valve seat cutter.
Yeah.
And is this a guide? Is that a valve guide there, or what is that piece?
No, I don't know.
No?
The plug. The plug for one of the, it's on like a clearance pocket plug. You can put it this way and you got a lot of clearance, and you turn it around and you'd have no clearance. You want to go this way.
Here you go, Mike. You want this? Mike, you want the mic?
Gotta let your head in here, it's a little low. Oh darn, the light bulb's out in here.
Oh well.
They do that on occasion. This is a tool room we have. And these are some of the tools that we use for certain repairs on the snows. They're just what we've gathered up over the years and just kind of specialized. There's one in here, this big bar. It's about 6-7 feet long and big mushroom end on it. And it's for driving a lot of wrenches. And we put it on a sling on the hoist and then get two guys on it and just use that big bar to drive the wrench, like pulling up the block rings on the rod where the rod's locked together. Takes a lot of pounding to get those loose or tight. And then behind us here, we have a big stack of
look at that.
rings that's the power cylinder rings. And you
those are all brand new rings, right? Ready to go in the engine.
Right, those are ready to go to be measured, turned. And as you can see up through the stack, some of them have a step and some of them are angled.
Yeah.
It just depends on how they were made in the first place. And when they cut that out, of course you bring that together and set your clearance.
Right.
And then you turn it to the diameter you want, and that sets your. But those are extra. One thing we can see right here above the rings too is our fuel supply to the engine. It goes into this piece of 12-inch, and that's what you call a volume bottle or accumulator, because you have to have, in a sense, a reserve of fuel gas. When that big cylinder calls for fuel, it's going to suck a lot of fuel. So we guess you could call it, we call it a volume bottle, or some people call it an accumulator. And it holds the gas in reserve. And then when the intake valve opens up, it has that extra for a big rush. And then it fills up again. So it's low pressure. We're only running about 4 ounces of gas pressure to the engine, but we have to have lots of volume. So we cut it with regulators about 3 times before it gets to the engine. And also here we have our rack of igniters, which is our spare igniters. After we take them out of the engine over to the shop, we build them, repair them, we bring them over here. And as you look at them, this is for a right-hand cylinder, which would be 2 or 4.
Okay.
And that's for the left-hand cylinder, which would 1 or 3.
Right.
And so you just come down here, you know you need igniters for whichever cylinder, and you just grab them and go.
And these are all rebuilt, ready to roll.
These are rebuilt, ready to go. Here we have specialized tool.
Seat cutter, huh?
It's a seat cutter for the igniter body. That's where the igniter is a tapered seat in the side of the valve chest. So we can run that in and bolt it up on the same flanges where the igniter bolts. And then run that reamer in and ream the seat in case we have one that's leaking a little bit. If they'll leak around behind the body. That's actually the tapered seat of the igniter leaking on us.
That's neat, Mike.
Right here is our valving for our starting stand.
Oh, yeah.
Okay. The water, the fuel, the air, all that is in these valvings right here. So that's how we control it. It's all under the floor that was on that starting stand. Okay, watch your head when you go up the steps here.
Okay. We've been in and out of this building here several times today. It's basically the same architecture. Is this the same era as these buildings?
Yeah, this was originally built at the same time. We call it the shop, and it has a machine shop. We have a lathe and a few things in there, generator, air compressor, and so we can go in and take a look around.
Let's take a look.
Okay. How you doing?
Okay, how about you, Mike?
Oh, not too bad. Thanks.
Good to see you.
Hello there.
Paul Harvey, Jack Simonsky,
Nice to meet you
Superintendent.
all.
Pleased to meet you.
Jack,
Tom
how you
Spencer.
I do, Tom. Nice to meet you, too.
Well, you got a great place here.
Oh, thank you. We appreciate it. It's part of our history, and I was just going over some old photographs here of the original station. Right now, there's about twice the size that it originally was, and we're just looking at some old photographs here of the original station.
So these photos are from like 1912, something like that?
Yeah,
Around that
right,
era?
1912 when we put the first engines in. Number one, they built big enough engine house for four engines.
Is that right?
And you can see it's about half the size of the
Wow, look at that.
Most all the buildings there are still there. There's one that is gone, little meter house. Was later torn down.
I think that would be that one, wouldn't it?
Yeah. It's right where the air tank sits now.
Yeah.
Right, and
Yeah.
we're in the shop building here now.
Right. That's right.
Uh-huh.
Boy, these are great old photos.
Well, we have a lot of history photos in my collection in Titusville. And we've shared those with Drakewell Park. They're going to start doing more on the history of the gas industry, along with the history of oil.
These are really neat.
That shows the wagon where they brought the main frame in across the river.
Wow, that looks like a heavy load.
Yeah, it is. I'm not sure. You remember, Mike, how many tons that main bed is?
We estimate it to be about 22 tons, but we're not sure exactly.
Wow, on a four-wheel wagon. Whew.
Yeah, that came by railroad down to Holton, and then was brought on by wagon the rest of the way down the far side of the river, and then forded across the river into the station location here.
Wow.
A lot of teams of horses.
There's another picture of the main frame here.
And you can see all the horses up there too.
Look at them all.
And there was
Wow.
just one team of horses that would work in the water to guide the wagon, and all the other teams were on this side with a big bull rope.
Is that right?
To the wagon to pull it across.
So the two horses on the tongue just steered the wagon across, and the rest of them pulled from on land.
From on land, correct. Yeah.
Isn't that incredible? Wow.
And we brought all the engines in, came in that way.
That is something. Geez, these are great old photos, Jack.
Yeah, it's nice to have some company history.
It sure is.
Our company goes back a long ways and was originally part of Standard Oil Company of New Jersey. Well, not New Jersey, Standard Oil Company. And William Rogers was the first president of the United Natural Gas, which was the company that built this, and a subsidiary of National Fuel. He was also the second chairman of the board of Standard Oil. He succeeded Rockefeller. So we have a rich history in the early oil business.
Wow.
And we have three major companies that were subsidiaries of National Fuel. National Fuel is a holding company, bought these companies in 1902. And we're made up of a lot of smaller gas companies, but the three major companies were United Natural Gas, headquartered in Oil City, Pennsylvania Gas, which was headquartered in Warren, Pennsylvania, and then Iroquois Gas, headquartered in Buffalo, New York. And all three companies had their own production. Iroquois Gas had the first underground storage in the world. And Queen Storage was the second one here in United Natural Gas, was turned over into storage from a production field in 1920. So we have a lot of history. We have many of the early pioneers of the company, of the gas industry, like Weymouth and Spitzglass, worked for United Natural Gas Company. Your flow equations for pipeline flow, your gas measurement, and that sort of thing were all done by old UNG people. So have a lot of rich history in this company.
That's really neat.
Very interesting.
Very interesting.
Can you tell us a little bit about the history of the station here?
Well, it again was designed as a production station. We have a big production field here, and was designed to boost gas up the transmission line pressure, which originally went to Buffalo. That was the lines that go from up at Overbeck station, which this station pumps into, is about 3 miles away, go straight into Buffalo, and they were some of the original natural gas transmission lines in the world. And Buffalo was the big market, and we had the gas down here in Pennsylvania, so we sent it north to Buffalo. And the station was built once the production field started to decline in pressure. The station was built to boost the pressure back up, the transmission pressure to go on up to Buffalo then. So the original line that was laid in here was a 8-inch line A, and then we laid line B, and then line C, and line C, and then line K. K's a 22-inch.
Wow, that's a good
line.
sized line.
It was a good sized line. Well, we sent a lot of gas to Buffalo.
Over a good many years.
Over a good many years, that's right. Some of these wells are drilled in the 1800s are still producing here.
Boy, that's incredible.
Do I recall that this was originally called Cross Station?
Yes, it was.
How that name originated?
Well, old company presidents or important people the stations were named after. And then in the 40s, the company decided to rename their stations to correspond with the township in which they were located. So that's, a lot of our stations had their names changed in Heath. It became Heath Station instead of Cross because it was in Heath Township. Yeah. So it, of course, was built in 2 sections. What, about 1915 or so, we built the 2nd section, so we can see that there was a lot of gas here to require as much horsepower there. There was originally 6 snows put in, and get pumped gas up to about 500 pound pressure and sent it north to Buffalo.
Is that what's in the main line now? It runs somewhere around 500?
The main, right now, this station's discharging at 300 into line C, which was one of the old original lines. Line C was laid about the same time the station was built, about 1912. And it pumps into that, but the gas, once it gets into New York State, the transmission line's been lowered in pressure. It is lower than in Pennsylvania. And so we're discharging into line C, which then goes into the main line at Lamont Station and goes north to Buffalo then, in the main line. But it is still capable of going to 500 pounds. And the FM 100 that comes through the station going east and west does run right around that 500 pound pressure. So we could still discharge into FM 100 if that's where we wanted to send the gas. But most of the gas still goes to Buffalo.
That's great, Jack. Is there anything else that you might want to add as far as Heath Station here?
Well, I guess I'm out of horsepower here. We have had some interesting horsepower added to Heath Station. Ingersoll Rand built a Wankel cycle engine, and we had a double Wankel in here in the 70s and early 80s.
A rotary type engine.
Rotary type, sort of like the Mazda engine in the Mazda car now. We had that. That came in under Cloak and Dagger. At the time it was moved in here, it came in very top secret, and for many years nobody was allowed to take photographs in this station because when it was brought in, it was the prototype originally, and the superintendent at that time had worked for Ingersoll Rand, and so he worked very closely, and as a matter of fact, he even drove the semi-rig down over the Belltown Hill because they sent a Flatlander in here to drive the truck in, and it was slippery, and the Flatlander wouldn't drive the truck down over the hill. So
I'll be darned.
Superintendent got in, Lyle Gilbert at the time, and brought that engine in, and we ran a lot of tests, and it ran for about 8 to 10 years, and didn't prove as reliable as the Snows, obviously. And so it's been since removed.
That's incredible that these Snows have been running since 1912, 1913. That's just incredible.
Oh, it is, and still running, and the boys do a good job of maintaining them. Every day we learn something new. Something will break, and it hasn't broken for so long that everybody forgot how to do it, and they have to relearn how to repair it. But so far we're still running, and it's history in motion. And company enjoys having that and being able to provide the opportunity for other people to see it too. There's not every place that you can walk into a compressor station and tour it.
That's for sure. That's for sure. Well, Jack, thanks so much for your time here today.
And I hope you enjoy your tour and learn a lot.
That's terrific. Thanks so much, Jack.
Thank you, Jack. Maybe
Nice
we'll go
to
and
see
see some of the engines run with Mike.
Okay,
now.
sounds good. Mike is very knowledgeable, and he can sure show you how the station runs. He's been here for quite a while.
That's great. Okay, Mike, what do you say we get started?
Okay.
Hey, Dom, it looks like we have some other Cool Spring people here today. So maybe we all can enjoy the tour. Here's John Hanley. John's come in from Lansing, Michigan.
Hi, how you doing?
How do you do, John?
Pleasure,
Tom
Tom.
Spencer.
Tom?
John, I know you've done some work on making a reproduction of the original snow blueprint, and I thought maybe you could explain a little bit of it. It looks like quite a project.
Well, thank you, Paul. Tom, this is the original print that was built by the company in 1912 with the first set of 2 engines that were shipped out here. Matter of fact, this particular is a print of engine number 1 in the station. And as you can see, now that it's some 82 years old, it's been a little bit damaged by contact with water. It's been stained with some bleach, or it has some major tears, and the print is starting to fade also from the light. Blueprints, once they're exposed to light, don't last a very long time. And as a result of that, we really needed to preserve this to help maintain the engines. So what was done is this was photographed in a large negative made about 18 by 24. And from that large negative, we produced a Mylar master print, the same size. And from that, we were able to make a brand new blueprint using modern technology. And you can see how much more readable this is. It has all been retouched, so all the tears aren't visible.
So accurate.
Yes, as a matter of fact, it's almost like a contact print, so the quality is very good. All the numbers are very readable. And this is very important because in many cases some of these engines are going to be disassembled and brought to museums. Not the case with this particular one, but one other one at the Cool Spring Power Museum. And having an accurate print to do the erection and set the engine up is absolutely invaluable.
Yeah.
And so part of the restoration isn't just the mechanical, it's keeping the documentation, the paperwork, and instruction manuals that are related to keeping the machinery running.
John, this is very interesting.
Now this print not only shows 3 views of the engine, but it also shows sectional views, and it shows the detail of the internal water-cooled piston.
Oh, look at
and
that.
There are 2 separate combustion chambers on each side of the piston with a set of intake and exhaust valves, and you can see the intake valve and the exhaust valve. The intake valves are rather impressive, as are the exhaust valves, which are water cooled. They actually pump water up inside the exhaust valve and back out to control its temperature.
I'll be darned.
They're very impressive. They stand about 3 feet tall, and the mushroom head on it is about as big as your hard hat.
I think Mike's going to show us one of those later. Boy, that's a great job, I'll tell you that. There had to be a lot of work went into that.
Well, thank you, Tom.
Every little detail is on that print.
Yes, even a parts list.
That is neat.
In some cases, over the years, people have made modifications to the engine too, and it's nice to be able to go back and look at the original print. How had they originally set them up? Here we're really lucky because at Heath Station there really haven't been any modifications to the engine. They're pretty much exactly the way they were when they were installed in 1912. Probably the only thing that's different is the paint color as they get periodically repainted over the years.
Right, that is neat.
Thanks, John. We certainly appreciate the explanation of this beautiful print.
Well, thank you very much, Paul, and thank you, Tom. I enjoyed showing it to you.
Thank you, John, very much. That's really neat.
Great.
Okay, we'll see you later.
Thank you.
Okay,
Bye
thank you.
Mike, I wonder if you could give us an idea of what kind of fuel consumption one of these engines actually uses.
Well, I can figure it up and tell you what we are using today. What we're looking at right here, coming up to our gauge board, what we call our gauge board, and it tells us, as we're looking right here, this is our high stage discharge gauge. It shows us what number 1, the high stage compressor, is discharging. The inlet pressure is what the gas is coming into, the pressure that's coming into the high stage, which is also, because we're 2-staging with the snows, We can look at it. It's coming in at 10 pounds to the low stage. It boosted it up to about 155 pounds. We take it out back and we cool it because the gas is hot and being compressed. Then it comes into the high stage at 155 pounds, and we're just shy of 300, about 297 is what we're discharging. And also, that makes heat in the second stage, so we take it out and cool it in a separate cooler. There's a low stage and a high stage cooler.
Okay.
All these gauges here, we do have one high pressure line that we monitor here. We can control it only through a valve. We don't compress and put gas into it, but we control it here. And by using a valve out on a meter run, we can control the pressure or the flow into the low pressure side of that pipeline. And sometimes we get orders from the dispatcher in Buffalo. He'll call me up. He'll say, I need to hold a pressure of 480 pounds on FM 100. That's the name of the line. So I go out and crack that valve, and it has a chart on it. And I'll look at the chart, and that tells me the pressure, and that's how I maintain that pressure. Every hour, we take a standard reading of the pressures that the compressors are putting out, plus the amount of gas coming into the station through the different field lines. We keep this logbook, which tells us what the pressures are in and out of the compressors, the speed of the engine, plus also our field lines through the meters that we're bringing the gas in. At the end of the day, we average that for a 24-hour average, and we come up with a total volume of gas that we put through. So I can flip back to yesterday, and it gives us, like I say, our average pressures through the compressors. And what we did in volume-wise was 5,900,000, or excuse me, 5,090,000 cubic feet of gas. And that's what we keep in our logbook.
And that was what was produced by this station yesterday.
That's what we produced through the station. That's the gas coming in. Now, the gas going out, we measure that too, but we discount our fuel because we use natural gas for fuel. And a lot of people come in here and say, geez, it's easy to do, your gas is free, but it's not. In a way, we pay for it because that's lost production gas.
It's fuel you can't sell.
And we have to meter it, and we do charge ourselves for the gas that we use because, yes, we can't sell it and we do burn it. And that is part of our operating expenses, so we do meter it. And you were asking me how much we use. I'll take this little orifice computer, it's called, and we can go over to the fuel charts and I'll try to figure out how much we're using in fuel.
Let's take a look.
Okay. The meters that were this set of meters right here is for one of our field lines. In fact, it's a line that comes from the Sigel area. And it comes from a little booster station, Eldred Station. Now, way back in the old days, Eldred used to have snows for compressors. And their field is a lower pressure field. So they have to boost the pressure to get it to come to us. So it's coming in at about 10 pounds. And the rest of our field, the pressure that we're holding here is about 10 pounds of pressure. We're not really pulling a vacuum on the wells. They're coming in under pressure. But this is the one meter, and it's called an orifice meter. I can pull out a plate here, get a decent sized one. That's a 3-inch. This plate goes in between two flanges on the meter run. You look out right out there, see that meter run right there?
Yeah.
Right in the middle, the long tubes where the flanges are.
Okay.
And there's two tubings coming off of that.
Right.
That's where the orifice plate goes in. And the way the meter works is it measures the difference when the gas goes through this orifice plate in the middle of the tube. It blocks the gas, so it has to constrict it. And as it flows through this hole, it's a very precise hole. It measures the upstream side and the downstream side. And the pressure is taken off the upstream side. The pressure difference, there's a slight drop, is on the downstream side. That pressure drop is measured in inches of water. And that's measurements are inches of flow. And so knowing what the pressure is plus the inches of flow through the orifice, we use this little orifice computer, and I can figure out the volume of gas going through this plate, orifice plate, either by the hour or by the day. And that's what we use to measure our gas. We also take the charts off once a week, send them away to our gas measurement department. They put it on a computer type measuring device, and it's a lot more precise measurement. So we do this for our own knowledge. So we can go down here to the fuel meter. All the meters, the blue line is the pressure, the red line is the flow, and then I know the size of the orifice in that meter tube. That's 6 pounds of pressure, 6 inches of flow through an 1.5 inch orifice. That gives me about 160,000 feet a day through that one only. I have another one. It is, of course, the same pressure. A little bit different flow. But it's in a smaller orifice. That's about 70,000.
That's cubic feet per day?
Right, so that's the two together. So we're putting about 230,000 cubic feet a day per fuel.
Through 5 engines.
For 5 engines. So
sounds like a lot, I don't know.
It's a lot. By today's standards, they're very fuel inefficient, but in their day, they were the thing. So when we're running the Waukesha back in the corner, it's a newer engine, higher horsepower, turbocharged, and it's more fuel efficient. So it does the same volume of compressed gas, about 5 million a day, for about a third amount of fuel that the snows burn.
Is that right?
Yeah.
Wow. That doesn't sound good for the snows.
Well, no, but like I say, it's one of the things that's the way they are. And by the way they're running, that's why they've been here 80 years.
That's very true. And they're pretty maintenance free too.
They are. Really, if you consider it, what we were talking about, the horsepower, 400 horsepower, for their size, they're in a sense, if you want to say, over-engineered, but they've lasted 80 years too.
There you go. And they could probably still be running 80 years from today.
If we took good care of them, I bet you they would.
Yeah. All right, Mike, that's very interesting. Thanks.
Well, we pretty much took a look around inside the building here and showed you how everything operates. You want to go outside and look around a little bit?
Let's do that.
Okay. Since we're right here, we can take a look at the exhaust for the engines.
Okay.
As you can see, there's 4 pipes here. That's the 4 engines, 1 through 4, on this end of the building. And you hear the way they are. There is no muffler on them. That's straight exhaust.
It's really pretty quiet for an engine as big as they are.
They are, like you was talking about earlier. They have a lower firing pressure, which makes a lot. And they're a 4-cycle, and they're pretty smooth. Now, if you listen real close, this one pipe, this closest one here, chugging a little bit more, that's the high stage. It has a little bit more load on it.
So it's working a little harder.
It's working a little bit harder. That's what makes it chug a little deeper. And this, we're not really sure why that's there, but we call it the chimney. And the only thing we can think of, it helped draw some of the heat out of the building. With the draft from the heat would come out the chimney and kind of draw the heat out of the building where the exhaust lines are, because they're uncovered the whole way under the floor. They're nice for heat in the wintertime, but it's pretty hot in there, as you just found out. Sure. This is what we call the firehouse. And And what we have in here is a 6-cylinder flathead Ford industrial engine, and it belt drives. Yeah, what do you think of that? It's belt driven to this pyramid pump. Now, back in the old days when they had company houses up on the other side of the road, plus the building roof at one time was wood. And so as part of an insurance deal, they had to provide their own fire protection. So out in the yard, as we're walking around, there's fire hydrants, red fire hydrants.
I see that all over, yeah.
And up where the company houses used to be, they had a row of fire hydrants up there at the company houses. But over the years, as they took the houses out, they cut back on the fire hydrants. But we still use it. We maintain it, run it once a week. We test run it. And here's our hoses on the little fire carts.
Yeah.
And
that's neat.
we use it for a lot more than anything. When we really use it, we use it for washing down stuff with. It puts a lot of pretty good pressure.
Yeah.
And this centrifugal pump here in the floor that's running, that's to supplement our water supply for cooling the snows. Now, we're pumping out of the creek with it. There's a little box out there, and that just helps supplement the water, because with 5 engines running, we need a lot of cooling water.
Very interesting, Mike.
And walk out here.
I see you got all kinds of valves and stuff in the ground out here. Those are all your lines coming in from your different wells?
That's all the lines coming in. Like looking up over that hillside right there, that's the F3 line. The one that I was telling you about comes from Sigel, from Eldred Booster Station.
Okay.
And then there's F88, which is a line that runs up over there. Back here is one, it's kind of hard to see, it's F89. Some of these boxes in the ground, that's where the orifice meters are. I was explaining to you.
Okay.
Some of them are above ground. It just depends on what they wanted to do with them at the time.
All right.
You can look back here at this meter run. Now this is the meter run for F3. The one I showed you and I was explaining to you.
This is the one that's got the orifice in the center of the pipe?
Right.
Is there a reason that they have the length and everything? That's all controlled, I guess, right?
Well, the length of it, and these are very precise pipes. They're very smooth inside. That's
really?
to keep,
it's special pipe and all.
Right. That's to keep the gas from being turbulent when it hits the. They want it to smooth out, so they give it a nice long run when it hits the orifice plate, so the gas is smooth and not turbulent, and it gets a good measure. Then
here's where you take your readings,
right,
the high and the low.
And that orifice plate is trapped right between those flanges.
I see.
And then we meter it. And so that's, like I say, this is the meter run for F3.
So these are the 2 lines right here that go over to the meter, right?
Right. And we have 2 different runs. If for some reason they want to change this one, change the plate, they can switch to the bottom run, blow this one down, and change the plate.
Hey.
We can walk over here. This tower, watch your head here, got a duck.
This is a valve in here, Mike?
Not so much of that idea.
What's inside of here?
That's what they call an actual flow regulator.
Oh, okay.
It's a type of regulator that we can supplement this line if we have to backfeed, because we have a lot of customers on that line, that F3 line coming from Sigel. And if for some reason it would be out of service, we can feed gas from here back through it to keep our customers in gas.
Oh, I see. So you need a couple of new tie wraps there.
Yeah.
Some of these pipes are pretty good size here.
Yeah, this is part of our, there used to be a building here over all these valves, but it kind of had a little accident one time. There's a small gas leak in one of the lines under the ground, and it fed back through the drain line in the floor of the building. And it had a little heater in it to keep it warm in the wintertime, and that gas leaked back through and kaboom, the roof came off. So they just went ahead and took the building down. Now this tower here, as I'm going to explain to you, is a scrubber. And it's an oil bath, just like an oil bath air cleaner, only it's for cleaning the gas. And so we bubble the gas up through the oil, and it has a screen type, a cone screen. And it blows it, the gas blows up the oil into the screen, and then it goes through the screen, and then the heavy oil with the dirt falls down. And every so often we clean it out, put fresh oil in it. So that all of our field lines, because it's the gas right out of the wells, and they do bring up sand sometimes. You can't help it. I mean, there's dirt, will come up. And just things like that. We clean our gas. It helps a lot keep our compressors in better shape. this is the high stage cooler.
So this is an air cooler then here, right? Instead of being water cooled, this is air, or is this?
No, this is water cooled.
Oh, okay.
The discharge gas out of the high stage snows, either number 1 or number 3, comes out, goes through, and inside that is a brass
pipe inside of a pipe.
Pipe inside of a pipe, and they're brass, and they're finned also.
Oh.
So that the gas goes on the outside, the water comes up the middle. This is raw water out of the creek. We take this water out of a little run that feeds in. It's called John's Run. It's very nice water because it's a small stream and it's completely shaded. There's hardly ever sees sunlight, so it stays pretty cold most of the time. It's very good cooling water for what we need. And then the drain goes out and into the pond, but as you can feel, it barely warms the water up at all.
This one here, a little bit. These are both cold, this one just a little bit.
And that's cooling the gas temperature from probably about 195 degrees to maybe 60 degrees, and it's barely warming up the water. So that helps a lot. The other cooler over there, it's a little bit more modern one.
Okay.
It's a tube nest, a type heat exchanger, but it cools the gas with raw water. But it has like an oil cooler tube nest. And it's a more modern one because, as you can kind of see up here, looking down across the pond, see the pipes in the pond?
Yeah, look at that.
Okay, that used to be the cooler, the gas cooler for the low stage snows. And that was the main reason the pond was built, was to cool the gas. And it has a header comes out, and then it's, I believe...
So that's obsolete now, you're not using that anymore?
It is usable.
Oh, it is usable, okay.
We keep it in service because if for some reason the other one, because we do use raw water, our biggest problem is when we have high water, we get a lot of pine needles and leaves and mud, and it'll pack that off on occasion. So we do need to clean it, and we keep this one usable, but the trouble is it has a tendency, because it's in the water and unprotected pipes, it has a tendency to rust through at times.
Okay.
But it is usable in extreme emergency cases. But it used to run all the time to cool the low stage discharge gas. And that was really the main reason the pond was dug, was to cool the gas. And then we also have our pump intakes, number 4 and number 6, with the belt-driven pumps in the basement.
Yeah.
They take their suction out of the pond. Can kind of walk down around back here.
Sure.
If you look up there next to the building, the pipe comes up and through a valve with a little horn on it. That's the relief valves.
If the pressure becomes too high.
For some reason, the discharge line would be blocked off. That relieves the pressure on the discharge line of each compressor. And they're set, the lows are a different pressure than the high stage. And we have a meter man, he'll come in every so often, I believe it's like twice a year, he has to pressure test those. And he can actually make them open by pressure testing them.
This is one of your intakes here?
That's the water intake for the pump under number 4.
Okay. Now this line running out, a big line, that's a gas line?
Yeah, that's the header for that gas cooler.
Header for that gas line out there.
Right. At the other end of the building, I was telling you, 1, 2, 3, and 4 exhaust that way. This is the exhaust for 6 and 8. They're pretty strong, isn't it?
Sure is.
If you listen real close, you can hear the exhaust for each cylinder.
Yeah, you can hear it. Why does that hit hard, like on one cycle?
Well, the only explanation we can really say is just the length of the exhaust line, because they all come down into one exhaust manifold. The closest closest cylinder, I should say, is number 1. And 4 has to come up
that much further.
So it just makes it.
And then what happens? They start mixing, right? The 3 of them mix in the same pipe.
Right. Yeah, a lot of people, that's music.
I love it. I love it.
different people have come in here and they actually have their own tape recorder, and boy, they'll go up and they'll hold a tape recorder right at the exhaust just to get that noise.
That's neat.
Well, is there anything else you'd like to take a look at?
I don't know, Mike. I think you pretty well covered it here.
Yeah.
Gosh, Mike, that was a great tour.
Well, I'm glad you could come up.
You know, as many years as I've been here, which I think is about 35, I learn a little bit every time I come here.
Well, we enjoy having people come up. It's something that
This is fabulous. This is like the 8th wonder of the world here. I think it's terrific. Really appreciate your time, Mike. This has been great.
Come back anytime.
Boy, thanks for that opportunity.
Thank you very much, Mike.
Okay.
We'll be seeing you down at Cold Spring.
Okay. Have a good trip.
Let us give you your hats back.
You do that back and get back to a Cold Spring. Yeah.
Okay.
Terrific.
Have a nice trip.
Thank you.
Thanks a
Have
lot,
a good
Mike.
evening.
You know, Paul, that was just fabulous. Just absolutely fabulous.
Well, it always is. Every time we come out here and just a little bit to listen to the exhaust as you walk out to your car and drive away, it's...
Listen to that music. That's just terrific. Ah.
I hope this is here for many years.
You said you had a surprise for me, and this is fabulous. Just incredible.